So anything you say could be used against you. All right. You guys good? Okay. We are doing 7.2 today. We're talking about similar shapes, similar polygons. Back row, you guys good?
Yeah. It's about recording.
Okay, why don't you tell me when we finish this lesson?
I don't need to tell you at all. Oh, that's fun.
No, you're
Sophomore mine.
sophomores, am I right? All right, so we're talking about similar polygons today. There are three things really that I need you to know about similar polygons. Does anyone know what's one thing that needs to happen for shapes to be similar? Not necessarily connected, same number of sides. Good, I'm gonna rephrase that to they must have the same shape. So if they're both triangles, they can be similar. If they're both rectangles, they can be similar. If they're both dodecagons, they can be similar, but not if one's a pentagon and one's a triangle. Anyone else know something else that needs to be true in order for triangles to be similar?
3 sides.
Not necessarily 3 sides.
A triangle?
For just a shape, a polygon.
Angle side, angle.
That's congruent. And we'll kind of actually get to things like that in a little bit, but not yet. Let me help you out. All corresponding angle pairs must be congruent. All corresponding angle pairs must be congruent.
That's what I was saying.
Is that what you're saying?
I was saying angle side.
Okay, but I need all of the angles to be congruent. I also need all corresponding side pairs to be this special word, proportional. Proportional, which means that they have the same ratio. Must all have the same ratio. That means they could be the exact same, but at the end of the day, they must have the same ratio, whether it's 1 to 2, 3 to 4, 5 to 2, 7 to 11. It's the same ratio all the way around. Remember that ratios are like A over B or A to B, like that. I don't know why he's so far along. Excuse me, right here. Be friends with that guy. This is how we did ratios yesterday. This is how we're going to continue doing ratios. Like Jada said, it has to be the same shape, so you can't have a square and a triangle go together. I like to do a little bit of notability magic with this. So I like to draw a little triangle, and then I like to copy and paste him. And then I'm going to make him way bigger. Oh, I thought I was.
Whoa.
Whoa! Isn't that insane? Is that big enough? Is that too big?
I think it's a little too big.
Okay, I'm so sorry. Too late though. Now, I know all my angles are the same. That angle is congruent to that angle. These angles are congruent to each other. And then these angles are also congruent to each other. Are their sides the same?
No.
No. That one is definitely a scale bigger than the other one. That gets into my next part. There's a name for that common ratio between these triangles. The ratio of the lengths of the two corresponding sides of the triangle. So ratio of the two corresponding sides is what we call the scale factor. Scale factor.
Oh, yeah.
Scale factor.
Don't you like your gravity?
You could graph these. You could do scale factors. We're not really doing any coordinate plane graphs right now. One thing before I jump along, this little curly guy means similar to. It looks like if I took a congruent sign and I got rid of like the equal underneath it. I took the congruent sign, I got rid of the equal underneath it. For my Spanish taking friends, it looks like the Nye in Spanish.
It's not P.
It looks like not P, yep. Very good, that means similar to here. So that little squiggly means similar to. So is there anything else I need to mention? Okay. And then the very last statement, this is something that we've talked about before with congruent statements. When I said this shape is congruent to this other shape, the order of the vertices matter. It matters that I put it in this order. A, B, C, D is similar to W, X, Y, Z. Which angle is congruent to angle A?
W,
W, why?
the third.
They start first.
Because they're both the first one, that's it. What about B? What angle is congruent to B? Good, what about C?
Why?
Good, what about Z?
D.
D, good. So because it's first, then it's the same as the first one of the other one. The two that are last are congruent. They all match up and they're in that order for a reason. Okay, so just like we did congruent statements. It also helps me know which sides are proportional to each other. So like in this case, CD would be proportional to what side? YZ, good. And I like that you were intentional saying YZ and not ZY. I need them to match up exactly. All right, so now we're gonna do an example with this first one. It says, given that triangle RST is similar to triangle XYZ, complete the following. Okay, time out. If I know that they're similar, what do I know?
That Y, that S. Put
RS
all the angles are Y, and
Let's start with all the angles that are congruent. I think I know what you're saying, Elijah, but we're gonna get there in a second. So angle R is congruent to what? X, good. Angle Y is congruent to, good. And angle T is congruent to, good. Okay, just wanted to make sure I knew what was going on. All right, so all the angles are congruent, and then what do I know about the sides?
you're doing it well. No, they're not congruent, they're proportional.
They're proportional, they've got the same ratio, good. So I know that they're similar, so I know that the ratio must be the same. So I'm gonna use the two sides that are given to me and figure out what's the ratio between them. It looks like there's only one side given to me in the XYZ shape, right? 15. Which side does that correspond with in the RST triangle? XY goes with RS, yes. Good, so I went from orange to blue. If the colors are helpful, orange to blue is my RS. We're gonna use that to help us find the scale factor between these two, okay? It wants us to go from RST to Y to XYZ, so we're gonna start with RS and we're gonna say that's over XY. Now, once I write it as angles, I wanna write it as a fraction of the numbers. So RS we know is 20. 20 over XY is 15. Can you simplify that down?
Yeah. 4/3.
4/3, good. You can leave it as 4/3. If you like writing it with the little ratio with the colon, go for it. That's fine as well.
So you only need one of those,
You only need one of those.
and you have to write that R S over X Y every time.
We are gonna do it in our notes because I want us to get familiar with it. Once you get to homework or test, unless I ask for the sides, you don't have to write that.
So if it's greater than one, then it's just bigger. If it's less than-
Good, now we're gonna go backwards. Now we're gonna find the scale factor of XYZ to RST. Do I need to do different math?
No,
What do I need to do?
it's the opposite.
I went from RS to XY. Now I want to start with XY and go to RS.
So why don't you do like X, Y? Alright. Why do you do why don't you do like all three? Wait, never mind. I'm confusing myself.
We just want the scale factor, which is just one number. And the only number that I have in the XYZ triangle is XY. So I have to use XY again.
Oh,
So I'm gonna do XY over RS, which this time is gonna be 15 over 20. And when I simplify that, it's just the flip, just the reciprocal of the other fraction, 3/4, or 3/4.
how do you get that R S?
How did I get RS?
Yeah.
I know that XY is corresponding sides with RS.
Oh.
We just used it last. Okay. All right, let's see. The next one says, find the value of X using a proportion. So now we're gonna set up a full equation, okay? Where is X?
X is going Y.
YZ, okay, good. And then which corresponding side goes with YZ? YZ is FT, good. I like how careful we were with that. Do you care how I make the fraction? Do you want XY or XZ on top or the TS or the ST on top? X,
I guess.
ST on top, okay, good. I couldn't say it again. This is like the third time I've taught this, so sometimes my brain gets like alphabet soup at this time, all the letters sound the same. So S over ST over YZ. All right, that I know, I don't know what that number looks like to you, but we're gonna call it a 16. ST is gonna be 16. So we'll say 16 over X. And we're gonna set that equal to which scale factor? Is it 4 over 3 or is it 3 over 4?
4/3,
Why?
because it's exactly how it's written.
Give you a little bit more than just it's exactly how it's written.
Which one's the first, the other one's first?
Okay, which one's first?
Yeah.
Yeah,
The RST is first.
good. RST is first and the 4 over third and in the one we just wrote. So because I started with the same triangle for the 4 over 3, I'm gonna set it equal to that. You can think about using that 3 over 4, but that's going from the XY first to the RST, so you'd have to flip the fraction that we made. I now have a nice little equation, 16 over X equals 4 over 3. Can you solve that? Do it.
Wait, how is it equal to 4?
Because I went from RST to XYZ. And so I used the scale factor that went from RST to XYZ.
X
It
equals
equals
12, baby.
Equals 12, good. Perfect. Now we could find the missing side, but it didn't ask us to, so we're not going to. The last thing says write a proportion that relates the corresponding sides. So just like I wrote this fraction, I'm gonna write 2 more with all of the sides relating to each other, okay? We're not gonna solve this proportion, we're just gonna write it so we see how they're related. ST over YZ. What's another set of sides that's related just like ST and YZ are? We did. What'd you say, excuse me?
X, Y, S, T.
X, Y, and S,
Wait, that's wrong.
okay,
R.
R. Should I do the X, Y on top or on the bottom? Y on the bottom, it just feels right. Why does it feel right to Jane to put that on the bottom?
Because X is color.
Not that X is always on the bottom or on the top.
Yeah, I do.
Yeah, that's okay, I love the confidence, so. Remember how the first one I set up ST over YZ? So anything from the triangle RST needs to go on the top, and
And this is on the bottom, why is he?
yeah, because of the YZ.
Oh, that makes sense.
So what did we say? SR over YX. Okay, yeah, I'm okay with that. And then give me the last one. It's the last sides that we haven't related, Grace. Oh, not sure.
DX.
ZX and then TR. So ZX and TR.
So there's like 6 sides that you can.
Oh,
relate and
we need TR to be on top. And ZX on the bottom. Okay. There's 6 total sides and 2 of them all go to each other.
How do you know the X is on top? Oh, because there's a Y X.
Mm-hmm. Yes. Yes. Okay, let's keep it moving. All right, next problem, it says determine whether the figures are similar. We do not know that they're similar here, but we're gonna find out. What's true? What's one thing that's gonna be true if they are similar?
Okay.
All the angles are the same. Let's see if all the angles match up with somebody else. Does W have a pair it matches up with?
Yeah.
With P, good. What about Z? Does it match with somebody? Good. What about Y? Good. And what about Q?
Okay.
Very good. Okay, so are all the angles congruent? Yes, all angles are congruent. Yes, we did that. Check mark. Okay, now what do I want to be true about all the sides?
They need to equal.
Proportional. All sides must be proportional. That's good enough. We gotta see if that's true. Okay, so we're gonna go through and we're gonna check that all of them are the same, and you need to show me all of them are the same in order to say yes that they are. Okay, I'll do the first one. WZ over PS. I'm gonna go WZ over PS. So I picked one side, I found its corresponding side. WZ is 9, PS is 6. What does 9 over 6 break down to? 3 over 2, perfect. Okay. Can someone give me another set of sides? What'd you say, Jake?
WXP.
WX and PQ. Good, so he picked the top WX PQ. That is 12 and 8. What does that break down to?
3 over 2.
3 over 2 again, nice, things are looking good so far. What's another set of sides we haven't done yet?
Yeah, or it's
Y.
Y.
Good, Let's do X and Y on top and QR on bottom, just like we did last time. We want all of one shape to go on top. So we're starting on the left and going to the right. So XY goes on top, QR goes on bottom, 18/12.
No, equal 3/2.
Does that equal 3/2?
So that's
Good.
factor, right?
That will be, but we gotta do one more. We gotta double check, make sure that last one's not a fake out.
YZ over RS.
Good, YZ over RS,
3/10.
15/10 is 3/2. Awesome. All right, so yes, that is true. And like we kind of mentioned about halfway through, we're like, oh, this must be the scale factor. Is it the right scale factor? Is it the scale factor from WXYZ to PQRS? Good. I kind of intentionally did that. I made us start from left to right so we didn't have to do more work later. So I'm going to say yes, because both of those things are true. Yes, these are similar shapes. My scale factor is at 3/2. And the last thing it says is write a similarity statement. Can someone write me a similarity statement? This shape is similar to that shape. Yeah, Nikki?
WXVY,
Let's go around all one direction, like that.
WXYZ.
Mhm.
And PQRS.
Yep. Mhm.
Yeah.
So I like to just kind of work my way all the way around so I don't have to jump and forget things. Yeah. So yes, WXYZ and then PQRS. Very good. All right, that's it. It's my scale factor and my similarity statement. Okay. All right, moving on. Anybody questions yet?
No.
Okay. Next one. It says these triangles are similar. Stop. What two things do I know if they're similar?
Then all.
Either proportional and
Sides are proportional. All angles are the same. Good. All angles are congruent. What are angles that are congruent here?
DACF and B.
Very good. D and A, C and F, and B and E. Okay, we know the sides are proportional, so I want to write a proportion using the letters of the sides, and then we're going to plug in the 6 and the 12 and the X and the expressions and all that fun stuff. So this proportion or this ratio is equal to that ratio. Give me one set of sides that are proportional to each other using their letters. I heard BA, and then I heard ED. Good. So if we start with B, then I want E to go next to B, and D and A go together. So BA and ED. We'll plug numbers in for that in a second. Give me the other set of sides that go together.
AC and DF.
Good. AC and DF. Awesome. So we've got a proportion set up. And again, I'm really fighting for these side lengths just because I want to make sure that we're really good on those. Now let's plug in what they actually equal. So BA equals what? Good, over ED, which is
ED is X much.
X minus 3. Good. And then AC is good. And then DF is
X plus
X plus 1. Good. How do you solve that?
one.
You do the cross one.
Cross multiply. Go. Do it. Did you beat me? Dang, did you write all the work I did? Oh, dang, I'm just old and slow.
Oh, I got it wrong.
Did you get it wrong?
X equals 7. Yeah.
I'm teaching on my heart, that's what I said.
I mean, I'm sure you could beat me. You guys are getting a lot of old and slow crap. today.
I think I mean.
Yeah.
Looks like light. It looks like skies are gonna be a little gray.
Nikki called me old earlier. Nikki and Carson told me I was old.
It's like.
What'd you find out?
Alive during when Adolf Hitler was alive.
Yeah.
And Also, wait.
Sister History was alive when Adolf Hitler was alive.
Here's the library, the civil rights movement.
Oh my,
Oh, yeah, for sure. The civil rights movement happened in like the sixties,
oh my goodness.
60s, 70s.
Look at this guy's again, look at this.
No, she wasn't alive like with Abraham Lincoln.
You know?
I don't know exactly how old she is, but she's.
That's like.
Yeah, 80s and
I
active,
feel like
dude.
it should be that one.
What do you mean?
I want, that should be like. Fund.
Yeah, I mean, you have to do your overtime. We'll offline more about sister later. I suppose just let it go, it's 13 minutes. Live generation. All right, focus. Read.
No one.
You have your phone in your hand.
She could have played tennis for.
That was our, I was.
Who knows what just died? Well, any of us could have played tennis with.
No, but like, they
Yeah,
both
so you
like.
like mine.
Oh, okay, I get it. All right, moving on. I've got one big problem on the backside, actually two problems, one big one little one. So let's get moving on this one. It says if quadrilateral ABCD is similar to quadrilateral EFGH, find the following. Okay, stop. If they're similar, what do we know?
I'm the angle.
Angles are the same. Good. So what angle is congruent to A?
E.
Good. What angle is congruent to B? Good. Sorry, those are almost the same color. What about C? Good. And what about D? Good. Okay, that's important. Now, all the sides are congruent. What do you know about the angle? Oh, no, sorry. I said that wrong. All the angles are congruent. What do you know about the sides?
We don't know.
We don't know all the sides on the second shape, but we do know the sides all together are proportional to each other. So the first thing we want to do is find the scale factor of A, B, C, D to E, F, G, H. So from here to here. Which two sides, use the letters, which two sides
H
could we
or
use?
D A and H E.
Good, I heard D, A, and
What are you
H,
saying,
E.
Oleg?
Oh, I was thinking something.
Jake said D, A to H, E, okay? Now, I know that they look like they're almost the same number. I'm gonna tell you right now, D, A is 8 and E, H is 6. So we're gonna make our little fraction of 8 over 6. What does that break down to be?
4 over 3.
4 over 3, good.
He's not dumb, awesome.
All right, we are gonna use this proportion, this ratio the whole time, okay? This is my new scale factor. That being said, I want to find all of the missing sides on that second shape. We want to first find EF. I'm gonna walk through EF with you and then I want you to try it on your own. Okay, so which side goes with EF?
AB.
Good, so we'll say AB is over EF. So what's my ratio for AB over EF?
20 over.
Sure, let's put X. And then Elijah, you want that to equal what?
4.
Good, 4 over 3. We're gonna keep that the same ratio. We're not gonna flip it or anything because on the other one, we had the first shape and then we went to the second one and we did the same thing when we did AB to EF.
Wait, that's illegal.
What's illegal?
Not illegal. I think.
Like,
Mathematically, you
what the-
can't do that. You can't just get 4 out of 3 without any evidence that it's 4 over 3.
She knows.
What essentially we're doing, Grace, is we're doing AB over EF is equal to DA over HE. So we're using the one from the equation above and then a new set of sides, but they should be proportional. They should have the same ratio.
Okay.
And that's gonna help me find X, right?
Yeah.
So let's cross multiply and solve. It is 15.
That's what it is.
Okay. I'm gonna be quiet. Can you guys find FG without me? And GH without me?
I don't know.
Okay, I'm gonna do my work at the same time. And I'll actually write out the whole proportion again, I'll say. Let's see.
I beat you.
I'm sure you did. I'm getting slow.
That's right. Give me some baby for you.
Bro, what are you about? Send this guy for the class.
Did you get 9?
I'm moving really slow. There's a lot going on up here. I'm getting really used and abused.
That's right.
I'll be okay. But
You got it, Miss White.
These sophomores these days, man.
Yeah, sophomores.
What about your kids? I'll help them.
It's definitely not my juniors, because I only have like 4, and they're doing okay
You have juniors in this class?
in pre-cal.
Wait, you only teach 4?
There's only like 4 total juniors in my pre-cal classes.
Are they sophomores?
Well, I have a bunch of seniors.
Oh.
I don't just have classes of 4 guys, don't worry, it's like still a 24-person class. Most juniors take algebra 2, because that's what you guys are taking, most of you guys are taking next year.
People in California, they are to a senior.
That's crazy.
My cousin did
Your
it.
GHM, why are you doing CBC, BA, etc.?
Because I gotta make sure my scale factor gets involved. I gotta set it equal to something, right? I can't just have 25 over X and call it a day. I gotta set it equal to something. I do get a decimal on this last one. Do you guys?
Oh, I see.
You should have.
I got a big desk.
I'm not there. Wait,
Why do you talking privilege or think?
yes, I got it.
Talking privilege is
What?
the talking privilege is sound great.
Yeah, why am I not talking?
As he talking more.
Hey. All right, do we have all of the sides? I got 15 and 9 and 18.75. Are we okay with that?
Right on.
All right, go to the next column. It says find the perimeter of ABCD. Can you do that? How do you do that?
8 plus 25 is 12.
8 plus 25 plus 12 plus 20. I know 8 plus 12 is 20 and 20 plus 20 is 40. 25 plus 40 is 65.
That's-
Mental math.
She's like that.
All right, now my perimeter of FGH, can you do that? We just found all the sides, right? We have 6, and then we found 15, and then we found 9, and then we found 18.75. 6 plus 9 is 15, and 15 plus 15 is 30, and 30 plus 18.75 is 48.75. Okay, questions yet? Now we want to do the ratio of the perimeter of ABCD to the perimeter of EFGH. Which one goes on top?
See,
Good, which is what number? 65 over
48.
Good. Normally with the ratio, I would tell you, simplify it out. What are your common factors? We cannot do that here though, because I can't do that with a decimal. Go ahead in your calculator, divide 65 by, or 65 divided by 48.75. What do you get? 65 divided by 48.75. 1.3 repeating, right? 1.33333. What's that the same thing as?
1 and 1/3.
1 and 1/3? And what's 1 and 1/3 the same thing as? 4/3. That's the same thing as 4/3, which is the same as the scale factor. So what the whole reason we did this whole problem was the rate, if 2 polygons are similar, then the ratio of their perimeters equals the scale factor. The very, very last problem we're going to do is going to use this concept. Sure, every time you could find all the missing sides and then add them together to find the perimeter. But I'm going to argue that if you have scale factor, if you know the perimeter of one of the shapes, you can find the perimeter of the other shape, okay? Last problem. It says if triangle DEF is congruent to triangle GHJ. Okay, time out. If they're similar, what do you know?
That's the angles are the same and their sides are.
Their angles are the same and their sides are proportional. Good. So we know all of their angles are the same. We know all their sides are proportional. Can we find the scale factor?
Yeah.
What do you want to do to find the scale factor?
Yeah.
So.
All right, you said DF and HJ? Or did you say EF?
Yeah.
Okay, sorry. D and E sound very similar. Jake said EF over HJ is gonna get me my scale factor. Okay. 8 over 12. What is 8 over 12 simplified down to be?
Equals to,
That's 4/3.
2 over.
3. Perfect.
3 over 2.
I was doing math.
We did EF over HJ, so we got 2 over 3. Okay, that's my scale factor. Can you find perimeter of one of the 2 triangles? Which one?
Yeah.
DEF, what's the perimeter of that?
40,
That's
30.
30.
30, so.
That's all right.
like,
Lots of carrying the ones. Okay, my perimeter of this one is 30. I don't know what my perimeter of this one is. I'm gonna put an X. Can I write a proportion with my 2/3, my 30, and my X in order to solve for this? What am I gonna write?
2/3, and then is it X over 30, 30 over X?
We had 2 on top, which came from EF. So does the 30 or the X go with the EF triangle?
30.
30. Because that came from this triangle. So we started here and then we went over there. So 30, we're gonna start with 30 and then go to X. All right, how do we solve?
You.
Let's multiply.
It's 45.
You can simplify first. I don't know if we can really simplify this one.
X
1 and 10.
45.
1 and 10. I don't see any 10s.
No, like 3 becomes 1.
Oh.
30 becomes 10.
Ooh, that is an excellent point, Grace, but you cannot cross cancel across the equal sign.
Oh,
I just want you to straight multiply.
Can you just? The other one.
Can you multiply what?
You know, more like 5 or they go 3.5.
Oh, that's kind of, yeah, you can, that's similar, yeah.
I think
You wouldn't want to multiply it by 1.5, you'd want to multiply it by,
30 times.
I guess you would multiply by
Oh,
1.5, sorry.
the skies are bright. this one.
The skies are bright, hope is out.
Like 30 times 2 is 60.
30 times 3 is 90. But 30 times 2 is also 60, you are not incorrect.
I did not.
All right, team timeout, homework. Homework, look at me. The first page, front and back, do not do. We're gonna do that next time. Do not do this page, skip it. The next paper is actually the exact same paper you just turned in today. You do not have to do it again. You can tear it right off or you can exit out. Do not do this paper, front or back. The one I do want you to do today is the 7.2, because what lesson did we learn today?
7.2.
Who would have thought? Front and back. The back is for quadratic formula problems. We will do more algebra either next time or 2 times after I see you. If you need the quadratic formula, it is on the board. What is on your homework tonight?
Front and back quadratic.
And then what does the front say?
I think 7.
Can I have these little really good thing?
No, you can wait till the prayer is over. Thank you for asking though.
No.